Hello guys, welcome to this session. Before we start, please make sure to subscribe to our YouTube channel. And then, so today we are basically going to talk about I'll take you through the formulas inside the chapter 12. Then we'll solve some one or two questions. So let me jump right inside. So I know you guys have probably gone through the reading already, so I'll just focus on the formula side, like this side. Okay. So one of the things I have to know is that when we talk about a position. Okay, let me just start with distance. So distance is let's say total distance is the sum of all the distance moved by the person. So if the person moved from point A to point B, the distance will be from what? A to B. If the person moved from point A to B and move from B to C, from C to D, from D to let's say B back, you have to sum all those distances. That will give you what? The distance. But when you talk about displacement, displacement will be like the final position of the person minus the initial position. That will give you what's displacement. So if you move from A to B and then what? From B to C, the displacement will be from what? C to what? A. That's the difference between the distance from what? Uh, C to A. Okay, that's what will give you the displacement. So it's just the final one. So if you look at from here, the body moved from where? The body, so the distance, the displacement in this case would be what? The final minus what? The initial. That will give you what? The displacement in this case. So now let's go back to the formula part. So we have average what? Velocity, and it's given by what? Displacement over what? Time. The change in x is the displacement. Change in x is displacement. And yeah, x total, that we'll talk about. So they are talking about velocity. And you know velocity is what? A vector quantity. So you need to use what? Displacement instead of what? Distance. So changing what? The displacement over time will give you what? The average velocity. Then velocity itself. So with this formula, when you are considering infinitesimal what quantities or instantaneous values, you see that when you take limits of both sides, you'll get what? V is equal to what? Dx over what? See, that's when time is approaching what? So these quantities become what? Very, 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 very small. So it becomes what? D instead of what? Change. It becomes x over dt. So that's one of the primary formulas that you guys are supposed to take note of. Then we have what? Average speed. Average speed is the what? Total what? Distance travel. So the total distance travel over what? Time. So if the body starts from here, from this point go and come to what? Let's say this point and then move here. The total distance will be you sum this distance plus this distance. That will give you the total distance. But the displacement will be like the difference between where the body starts, where the body has stopped, and where the body starts from. That's what will give you what's the displacement. Um, let's see. And they have some other things over here. Now they are talking about acceleration, and the principle still remains the same. So acceleration is equal to what dv over what dt, and then or you can also get acceleration by what differentiating distance what twice, the displacement twice. That's if the displacement is not a constant. If you differentiate it twice, you get what the acceleration, and then the relation between acceleration, velocity, and distance is what a is equal to v dv over dx. I want to say something, but when you reach the question side, then we'll talk about those things. So in summary, these are the formulas that we have. Uh, yeah, basically you guys know this things already. Just the application side that you're supposed to talk about. Now, this particular part is for constant acceleration. Now, when the acceleration is constant, and when you integrate, you should get all this. You get v is equal to what? V naught plus AC. AC means what? Constant acceleration. ACT. Then Vx is equal to x naught plus what? U naught T. Yeah, those things. Make sure, say we even give them at the back of this one. So if you need it, I just refer back to that to them. So okay, let's talk about erratic motion. About examples, I'll solve some examples and put them at the end of the video. So yeah, continue watching. You have examples at the end. So erratic motion. So erratic motion is basically like the body is taking different paths along its trajectory. Like as you can see from here, the body moves along what a curved path from what the point zero to this place. Then you move along what a straight path. That's what erratic motion. It is what a random motion. The body move like this, move like that, and all these motions have what different what equations. Okay, different equation. And how you tackle this first type of question is I usually use what time limit or the time. This one has distance, so you use what distance as a range. So you basically you just state what this is from 0 less than what x less than what 625, and the equation they use is what v is equal to 0.6 x raised to the power 3 over 2. So if you write the limit at the top, that's the distance limit, and you have the equation at the bottom, you'll be able to determine whatever they're asking you to determine. Then there's some things that you guys need to take care of. So you know that when you are traveling from here to this place, okay, you have talked about those things in the other video. But you let me just if you are traveling from here to this place, like when you're talking about velocity, you realize that the initial velocity here is what? Let's say 0. The final velocity for this particular part is what? Here 75 what meters per second. That final velocity will serve as what? The initial velocity for this what second part. Okay, for this second part. That's why when I ask you to find like the final time over here, you need to make sure that you consider all these options. Like the final velocity here will be what? Will be the initial velocity for this part. And if since this one just ended, it means that the same velocity will be at the final portion over here. Um, yeah, this is an example over here. The body, the distance. So it starts with it move from 0 to what for 30 seconds in one what in a different what path. Like you can see this part 0.4 this one. So you can start by writing on limits 0 this distance time. So 0 less than t less than what 30 degrees 30 what in seconds. And then this one the part the equation of that part is what x equals 0.4 t squared. Then you can state another what limit from 30 to 40. Then the equation used is what? The one at the top. X equals 24 t minus 360. Give up. So with that, you'll be able to like have your things well presented and you'll be able to find what you're looking for. I'll try and solve some examples of what I'm talking about. Okay. Yeah, don't worry about this part. We'll talk about it. Should we move to? Okay, so I'll solve this question first. Let me solve this question. So basically, you see that it's an erratic motion. The body move in what? Two these two pathways. First, the first pathway from 0 to 10 seconds, the body was traveling on the path where its relationship with t is what t squared. Then from 0 to from 10 to 30 seconds, it's travel in a straight path, which is what 20t minus what 100. And when they are asking us to what construct what a vt velocity time and what acceleration time graph between what 0 to 30 seconds. So what you do is you split the two things into what two parts. Okay. So 0 to what 10 seconds and 30 seconds to what 10 seconds to 30 seconds. And then we know for this range, x is equal to what c squared. And to get velocity, you need to differentiate what s. If you differentiate s, you get v. Or you can also write that v is equal to what dx over dt, and when you differentiate, you get what 2t. And then you need to find what the velocity at the end of the limit. Okay, that's what you're interested in. You need to find the velocity at those ends. So you substitute what 0 inside the velocity, then you get what 0. Substitute the end limit, find velocity at 10, which will give you what 20. You do the same to this part. This one, its velocity, its distance, like the distance time, this one is given by 20t minus what 100. When you differentiate, you get v is equal to what 20. That's the velocity. It means it's what along this line, the car or the body was moving with a constant velocity, which is what 20. So you come and draw your velocity time graph. Then indicate this place at what velocity. And then indicate this one. This one is what the maximum reach was what 20. 20. And then so from 0 to what 10 seconds, you realize the acceleration starts from 0 and increase to 20 seconds. Start from 0 and increase to 20 seconds. And from that place, between 10 seconds and what? Between 10 and 30 seconds, the body maintained a 20 acceleration until it reach what? These 30 seconds. That's what you are interested in. So you don't know whatever happened to the body, the velocity after this end. So you just stop here. You don't complete it with what? Like a complete line or you bring it to 0. No. The body, that's where we are interested in. So that's where we stop. So you can basically do the same thing for what? The acceleration. So you take this and you know acceleration will be when you differentiate, you get what 2, right? So when you differentiate this part, acceleration will be 2. When you differentiate this part, acceleration will be equal to what? 0. Then you draw your line. So when you draw the line, you should get something like, let me just draw it here. So you indicate your time 10 seconds, 10 seconds. Then this place will be 30 seconds. Okay. So then this is your acceleration. So you come in 2 meters per second, maybe let's say somewhere. Let's say 2 is here. 2 is here. And then this 0. So the acceleration, the body has a constant acceleration from here to this point. Okay. Between 0 and 10 seconds, the body has a constant acceleration of 2 feet per second squared. Then its acceleration becomes 0 at this end. Okay. Between 10 and 30 seconds, the acceleration becomes 0. So you just complete this one. It's a dotted line. So that it has come down to this place. So that's where you are in. If it was negative, then would have gone down and draw the negative part of this acceleration. I hope you guys understand this solution. I'll also this one like that. Let me just I'll do this. So first you have to extract the information inside this. So you know that from here, you should know that from 0 to 10 seconds, the body has a constant acceleration of 10 meters per second. And then between 10 seconds to t prime, the body has an acceleration of negative 2 meters per second. That's a deceleration. Okay. So you write that down like we did in the first one, from 10 seconds to this, you have that, from this to that. If you want to use the like a, so what they're asking here is we need to determine what the time needed. First, we need to plot this, but we need the time needed for the car to stop. So the rationale behind this one is that for the car to stop, if the car stop, it means that its final velocity will be 0. See that its final velocity will be 0. So what you do is you use this range from 0 to 10 seconds to find the final velocity at this point when this one is 10 seconds for this part. Okay, you find the final velocity for this part. So you do a is equal to what? So you just have a is equal to 10 is meters per second, right? So you can do a is equal to dv over dt, and then 10 dt is equal to dv. So you start velocity will start from 0 to v dv, and then the time will start from 0 to t. Then you should get v to be equal to 10t. And v is equal to 10t. Then from here you can be able to find the initial and the final velocity for the first part. That's the one having the 10 acceleration. So when you input v is equal to 0, you should get the velocity at time 0 to be equal to 0, and velocity at time 10 seconds to be equal to 100 meters per second. So that will be the initial. So it means that the body started from 0 to 10 seconds. Okay. Between that time, its velocity was it moved from 0 to 100 meters per second, right? So you stop there. So at this point, it moved from 0 to 100 meters at 10 seconds. So at this point, when you draw the graph will look different, by the way. You just draw the velocity time graph. So at that point, the final velocity, which is 100 meters per second, will serve as the initial velocity for this other path. For the path here, that's the area 2, between 10 seconds and t seconds. So you now state that between 10 seconds t and t prime, the acceleration is equal to negative 2. And when you find the velocity will be equal to what? So you will do the same thing. A is equal to dv over dt. And then negative 2 dt will be equal to dv. Now you are going to take the integral. So integral, you know that the time now will now start from 10 seconds to t. Okay. So the time will now start from 10 seconds pardon, to t, and then the velocity will now start from 100 meters per second. Like I said, the final velocity for the first motion, the first part, will be the initial velocity for second part. So the initial velocity then will go to from 100 to a v, which we don't know. When you integrate this, you get negative 2t, then the limit from 10 to t to be equal to v from 100 to v, the limit. So then if you substitute this thing, you should get negative 2t plus 20, and this should be equal to v minus 100. So your velocity will be equal to negative 2t plus 120 meters per second. So that's your velocity. Okay. Now we can, so this is the second part. So now we can now apply our rationale. That's before the body If the body stop, then it means that the final velocity for the second part will be equal to what? 0. So we can use that to find the final time. So we can equate what? Negative 2t plus what? 120 to be equal to 0. When you solve that, you get t to be equal to 60 seconds. It means that what? The final t, which is the t prime that you are looking for, is what? 60 seconds. From here, you can be able to solve the other things and then plot your graph. Nice.